do an additional example with multiplying radical expressions. Scroll down till you find Algebra 1 9.1 to see the original equations. Here I have two binomials being multiplied together, and of course the FOIL method would work. And in fact, I started out with the FOIL method, but what I found was that it was really lengthy. So it's going to be actually quicker to just go ahead and break down the square root of 40 and the square root of 20, and then work from there. So the square root of 48, we know that we're looking for a perfect square that goes into 48, and 4 works. Well, if 4 ever works, check 16. Does 16 go into 48? You may have to use a calculator to do that. But 48 divided by 16 is 3, so it does work. I put the perfect square in the front and the one that's not perfect behind it. And then I take the square root of 16, which is 4 root 3. So in this binomial, I have root 3 plus 4 root 3. And there's an invisible 1 right here. And you're going to add the coefficients if the radicals are the same. So 1 plus 4 is 5 root 3. Okay, in this binomial right here, 20 needs to be broken down. Is there a number that goes into 20 that's in my perfect square list? Yes, 4 does. And I'm not going to check 16 on this because I know 16 doesn't go into 20. I will turn that into the square root of 4 times the square root of 5, because 4 times 5 is 20, and I want the perfect square in front. Square root of 4 becomes 2 root 5, and then I have minus root 5. There's an invisible 1 right here. So 2 minus 1 is 1 root 5. So basically I have 5 root 3 multiplied by root 5. 5 times invisible 1 is 5, and 3 times 5 is 15. And that 15 won't break down. So this is my answer.